It's 10 a.m. at the Wilson Elementary School in Mequon, Wisconsin, and time for mathematics. This third grade class is about to investigate division using items brought in from teacher Lorraine Barr's kitchen and cupboards.
Today we're going to do an activity to find out how we can use division in our life and how you might use division when you're out of math class. Now, I have a problem. This happens to be my favorite breakfast cereal, and on here on the package it tells me that 1 ounce is a serving. So I'm supposed to eat 1 ounce of this cereal every morning. But what information do I need to know in order to find out how much 1 ounce of this cereal costs? We've been working on division for about 3 days. And basically, they just had an introduction to division.
The price?
I'd have to know the price of
the cereal.
The price of the cereal. And on the top here, it does tell me the price of the cereal. Is that all I need to know?
You need to know how much it costs and how many ounces are in it.
Okay, I need to know how much it costs and how many ounces are in the package. And what I'm going to do is I'm going to give each group a piece of paper and a marker. And I'm going to give you an item. And I want you to look carefully at your item because I've got more things in my bag here, not just cereal. Your job then in your group is to draw a picture to find out how much 1 ounce costs or how much one item costs.
20 divided by 205. 5 divided by 205. No, it's 205. The price is 205.
I know.
Where is it? Here.
5 divided by 20.
I know, that's what I said.
But how are we going to draw a picture?
Only your group should be hearing
How
you.
are we going to draw a picture?
What are you going to do?
Yeah.
20 little bags. Divide them.
Divide them by what?
Divide them by
20. But you can put the equation down below.
Yeah. So
How could you divide this equally
You divide
among
the
us?
price among each pair of socks, like, and then give each one pair. Yeah, each sock like $1.
You could give each sock. David said, give each sock 1 cent. Give each sock another cent. Give each sock another cent.
Or you could
And
do dollars.
you could do dollars.
Yeah.
And then once you get down to dollars,
3 times 9. Then you pay 2 cents. $3. 1.
What if for 1 cent over?
Well, then you have to divide it. You can't be 1 cent over.
Then that would be $3. So we have $9.
But they only cost $8.99.
Put another dollar. Put another dollar. Then you'd have $8. And then you only need 99.
so because see that's 3, 5, 7.
Then you could do 33 cents for each one.
Yeah.
They all cost $2.33.
Now that you have your 20 bags here, our purpose is to find out how much one bag costs.
Like 2 cents, and that would be 2 cents. And like that, and that. And if when you're done, and then he goes up to 205, then that's how much each bag costs.
Does that make sense what he said?
Yeah.
So you would start out, do you think it would work to start out with 2 cents here and 2 cents here and 2 cents here and 2
Yeah,
cents
and
here?
then if it doesn't work, you can go higher.
Then you could go higher.
Odd number.
Okay, so do you want to start with 2 cents or do you want to start with an odd number? I don't know. That's something you want to decide. You're going to start with 5 cents. Okay, go through and see what
Yeah, I
happens.
think that's it.
5, 10, 15, 20, 25, 30, 35, 40.
27, 36, 40. Wait, go all the way up to 12 because you know 108 is 12. So go all the way up to 12. And then, now what do we do here? 108 plus 9.
108 plus 9 is
112 plus, yeah. 117.
yeah, 117.
125. 134.
134.
134. 143. Yeah. Yes, that's right. And then 143.
152.
Yeah, 152. And then
161.
100. Yeah.
170.
100. Yeah. 70. 179. No. So let's try to take. Wait. Did we go over? Did we go over on the 11?
We went less.
Yeah, we went 12. 12. No, we went over on 11. We did?
Yeah. So it has to be in between 11 and 5.
No, 11 and 9.
Well, 99?
Yeah, 99 plus another 99, you'll get $1.32. $8.77. No, $1.
How far is 99 cents from $1?
A cent.
1 penny off. Okay, you could figure this out as a...
So we take one off each, so that would be 3 off, so that would be 97 cents. $8.97.
$8.97. Is that pretty close to this?
Yeah.
So would you be correct in saying that one pair of socks cost about this amount?
Yeah.
Then I think you got it worked out. Okay, I would like you all to stop. Could we have a volunteer from one of the groups come up and at least, even though you don't know yet what the answer is, could you at least show us what you were starting to do?
We had an idea that maybe we would draw 15 asparagus as kind of just like a drawdown. Well, we couldn't get it. We kept on we tried doing 225 divided by 15. But
I knew that we were going to end up with some difficulty with figuring out price, but I also wanted it to be a real-life situation. And if I'm going to tell them to use this experience in the grocery store, the items that they choose are not going to come out to be exactly right.
cents, and we came out with $3.15, and we wanted to come up with $2.25.
What could help us out with these division problems?
A calculator?
Okay. How many of you agree that a calculator would help? Well, then let's use a calculator. Raise your hand when you think you know the price of your item. What did you find out? Brad, would you tell me what item you had?
We had the taco shells.
Okay, you had the taco shells. What did you put in your calculator?
We put in $2.09.
Okay, which is the price, divided by...
I didn't figure the ounce up.
Okay, were you figuring ounces for your package?
I was trying to.
Is that what you were figuring when you drew your pictures? What were you drawing pictures of?
Taco.
Tacos. Why taco shells? Why did you choose taco shells?
Because there's 18 taco shells in there.
Good, there are 18 taco shells in here. So you divided your price. You should divide it by 18. And what did you get for an answer?
It was a high.
Tell me what you got on your calculator. Then the rest of you need to be listening, please.
I got 116.
Now, does there happen to be a point in there?
Yeah.
Okay, so does it start with a point?
Yeah.
Okay, then you got 1, 1.
6. 1, 1, 1, 1.
Oh my goodness. What is that telling us about these taco shells? Arun.
Well, it's worth 11 cents with a remainder.
He said it's worth 11 cents with the remainder. Look at that number I have on the board. Is that a way to write 11 cents? 0.11. And all of the numbers after that, as Arun said, is a remainder, or it's part of a cent. So this, as Brad told us, this one taco shell would cost a little bit more than 11 cents. So when you see that big long number on your calculator, all you really need to look at are the two numbers that come after the period. Now, I would like everybody to figure out this item. And I will tell you the price and the number of ounces. We've got $2.55. And there's a total of 16 ounces in the package. Now, when I go to the store to buy my cereal, though, I always have a problem because my cereal happens to come in another size. So now, I don't know which size I should buy. I want to make sure that I get the best value for my money. What should I do now in order to tell which of those is a better buy? Where should I put my money? Okay, Arun?
Take the price. You can take the price of the grape nut that you just put and then divide it by the ounce or the item.
Okay.
And then, like, if it's like 16 cents or like 15, you should take that one because it's like a better deal.
Okay, let's figure it out and see which is the better deal.
Okay.
This package costs $3.48, and there's 24 ounces in the package. Okay, Nicole?
0.145.
And no, not any more numbers, right? Okay. So could we say that this large box then costs 14.5 cents for 1 ounce? This small package costs 16 cents an ounce. Do I now know which is a better value?
Yeah.
Which I should buy? I don't want my students to think that math is only the operations, only adding and subtracting and multiplying and dividing. I want them to know that math is used all the time, every day, by everyone. So whenever I can, I try to bring in something from the outside to show them how what we're doing in the class relates to real life. So that when they leave my class, they don't automatically shut down math, but instead I hope that it opens up their eyes, that everywhere they look and everything they see, they think math.
What division strategies did students use to investigate the assigned task? Discuss the use of calculators in this lesson. What other problem-solving strategies could students have used to explore this problem?